When designing an optical network, one of the fundamentals is calculating the optical link. But how is it done exactly, and what are the typical pitfalls? If you want to find out more, stick around and we'll check it out. Calculating an optical link actually isn't that difficult. It's basic maths. So the first thing that you need to do is work out what the optical power budget is. And to do that, you look into the datasheet of the transceiver and have a look at what the transmitting output power is. In this case, -1 dBm. And also you will have a look at what the sensitivity of the receiver is, in this case, -16 dBm. Now what you do is you take the delta of those two values, which is then in this case 15 dB, and that then is the optical power budget, which you then have to work with for this optical link. Now the next step is to work out what the losses are over that fiber link, and every single component in that link will introduce a loss. First of all, talking about fiber cable, the fiber cable will introduce a loss per kilometer. So the longer the distance, the higher the loss. Every single connector, every single splice will also introduce a loss. And of course, if we're talking about a WDM setup, the multiplexers and demultiplexers will also introduce a loss, and it is also definitely important to check the data sheet to make sure you're working with the right loss. Now what we then need to do is we need to take all of those values and we need to add them together, maybe add a little bit of margin, and then the sum of all those values needs to be within the optical power budget. So okay, let's say we've added that all up, we've got 14 dB of losses and we've got an optical power budget of 15 dB, so yay, everything will work. Well, probably, but reality and theory can and will probably sometimes differ quite a lot because there are some variances that can distort that calculation. So let's start off with the wavelength that is being used. Fiber has a higher attenuation at 1310 nanometers than it does at 1550 nanometers. We're actually talking about 0.1 dB per kilometer. That may not seem a lot, but if you're thinking about a 30 kilometer link, that's an additional 3 dB of loss. Also, not really part of the calculation, but still very important to consider, is the dispersion. For longer distances, dispersion can affect the signal integrity. But then we've also got fiber degradation, so macro and micro bending of the fiber, and also we've got the laser degradation, so meaning that the output power of the transceiver can decrease over the course of time. So the point is that it is good to work it out in theory, and that gives a good indication if it can or cannot work, but a better way of doing it is actually working with values that you've retrieved from actual real-life measurements. Now that of course isn't always possible, you can't always access the fiber cable in the ground, so the next best thing is having a measurement in the lab. Now there are two main pitfalls here in the lab when doing such a measurement, and the biggest one is the so-called overload level of the transceiver. Because the transceiver doesn't only have a sensitivity level but also an overload level. And the overload level basically means if you put a light signal into the transceiver that is higher than the overload level, then you will not only just see errors, but you can literally damage the receiver. So, but the point is also that there are a lot of transceivers out there, especially for longer distances, where the output power of the transceiver exceeds the overload level. So in other words, if you're just measuring the transceivers by themselves with nothing else in between, then you will damage or can damage the transceiver if you connect them directly to each other, and that's why you then most definitely need to add attenuators to the setup. Talking of attenuators are a great alternative to using fiber spools, but always keep in mind they do not simulate the dispersion. So, what do we do if we've calculated everything, even with the measured values, but with borderline, or maybe the losses are higher than the actual power budget? Well, of course, you can consider using higher power and lower sensitivity transceivers. You can also look into optical amplification, but that isn't always what you want to do, because that adds a lot of costs. Also, power consumption goes up and all these sort of things. And in that case, I can only suggest that you talk to my HUBER+SUHNER customer solution engineer colleagues, because they have a ton of experience in this because it is their day-to-day business designing optical networks and also calculating them. And also, especially when it is borderline, we also have the option of designing specific WDM modules that have introduce a lower insertion loss so that you can still use those standard transceivers for your setup. So, I hope you enjoyed this video and that you learned something today. If so, please leave a comment. And of course, remember to follow our channel so you get your regular dose of brain snack. Until next time, bye-bye.